Hello, this is Mrs. Ward, and I'm going to go over some of the notes from section 6.2, the area. So remember when we first started talking about calculus, we said there were two main areas of studying calculus. One was to find the derivative or the tangent line problem, and the second problem was to find the area underneath the curve. So today we're starting the area underneath the curve. Actually, we started it last class when we started talking about the integrals. So there's three ways to find an area underneath the curve. And when we talk about an area underneath the curve, we're talking about solving the area in between the curve and the x-axis, because you have to put some boundaries on it in order for it to make sense. So we want to find the area between a curve and the x-axis, and then I'll give you some x values for a given bounds of x. So what that means is if I have my xy axis and I have a curve, it does something like this, and let's say I go from 0 to 3, I'm going to want to find the area underneath the curve between the x-axis. That's what I'm doing. And there's three ways to do it. One is going to be the definite integral, which we practiced finding an integral last section. We'll continue that later. One is what we're doing today, which is area. And what we're going to do in area is we're going to divide this shape into a bunch of little rectangles and find the area of all the rectangles using summation. And then the third and final way is to use shapes, geometric shapes, when it's possible. So let's talk about this one first. In order to do this, as I said, we're going to try and find the area, and we're going to form these rectangles. Well, I could make one big rectangle and find the area, and that would give me an estimation for the area, but it wouldn't be very exact. If I sat there and drew more and more rectangles, it would give me a better area. So that's why I'm going to have to use the summation. And I believe you guys have not seen the sigma symbol before, but if you have, please excuse me. This is sigma. It's a capital Greek letter. And the I is the index. That tells you what term that you're on. The N is what I'm going to call the upper bound. In other words, that's going to be the last x value I start with. This number here is going to be my lower bound. So when I was talking about finding the area underneath the curve, if I have something like this, and let's say the curve goes like this, and I want to find the summation underneath the area of the curve, and we'll go through this later, of I is equal to 1 to 7. If this is 1 and this is 7, I would be finding the area in between those two places. This A sub I is going to be the formula that's going to give me the ith term. So it's a lot to throw out at you, but let's just talk about sigma first of all. To evaluate sigma, what you're going to do is if I have I is equal to 1, so my lower bound is 1, my upper bound is 7, my function or my term is just I, which means I'm going to start by putting in 1, so I'd have 1. Summation means that I'm adding, so I'm going to do plus, then I do 2, plus 3, plus 4, plus 5, plus 6, plus 7, and I'd stop at 7 because that's the upper bound. And then I'd actually add 1 plus 2 plus 3 plus 4 plus 5, 6 plus 7, and I would get a sum of 28. So let's look at another one. Here I'm starting with k is equal to 3. It's okay that we change letters, that's fine. K is equal to 3. I want to do k squared, and then I'm going to stop when I put in 8. So I'm going to have 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. And finally 8 squared. So this will be 9 plus 16 plus 25 plus 36 plus 49 plus 64, and I am going to get a grand sum of 199. Now you have to be thinking that this is going to get tedious after a while, and we'll go through how to fix that in a second. So here I'm starting with I is equal to 0, and I'm putting it into this, so I'm going to do 2 times 0 plus 1. That's going to be my first term. Then I'm going to put in 1, so I'm going to have 2 times 1 plus 1, then 2 times 2 plus 1. I'm just going down here, 2 times 3 plus 1, and then finally stopping at 2 times 4 plus 1. So when I do this, 2 times 0 is 0 plus 1, so I'm going to have 1. Then this will be 2 plus 1, so that's 3. This will be 4 plus 1, so that'll be 5. 6 plus 1 will be 7. And then finally, 8 plus 1 will be 9. And when I add those all up, I get 25. Now, you got a little sneak peek. It says finding the summation using your calculator. So what I want you to do right now is I want everyone to get out their calculator, which I haven't done yet, so give me a second. Okay, so now I have my calculator out, and I'm going to go to a calculator page, and I'm just going to use the scratch pad. And I am going to do these using my calculator. So I'm going to go back up here. And the first thing I have to do is figure out how to get to the summation formula. So there's various different ways that you can do it. Probably the most direct way for you guys is to hit that button next to the 9. That's where we went last year for our matrices. And last year, remember, we used a matrix. Well, the one right next to it will be the summation. So I'm going to hit enter, and I'm going to have this box. It does not matter what letter you use for as long as you're consistent. So if I use X, that's fine. If I use I can use I. I'm going to go over, and I'm doing A, so I'm going to put in 1. Then I'm just going to click the right arrow key, and that'll put me into the term spot. And I'm just going to hit X again. And then I'm going to hit the up arrow key, maybe not. And when I hit the up arrow key, I'm going to hit 7. And that's going to do the 1 plus 2 plus 3 plus 4 plus 5 the whole way through. And when I hit enter, it's going to give me the same answer that I got, which is 28. When I do the second one, again, hitting that button, I am going to start, let's use I this time, or I think they use K, so let's use K. And 3. Then my formula is K squared, so K squared. And then hitting the up arrow key, I am going to stop at 8. My calculator is going to do all those calculations, and I'm going to get 199. So now let's talk about the properties of sums. So if I have something that's written like this, where I have K times A to the I, that K would be a constant, which means I could multiply every single number by that K and then add, or I could simplify matters and just bring the K out in front and then do the A sub I. So you can pull a constant out in front and then multiply the sum of those numbers without that constant at the end. If I have the sum or difference of two separate terms, I can separate that as the sum of AI plus or minus the sum of BI. And these two become very important when I talk about my summation formulas. And here are my summation formulas. Anytime you're going to need them, I will give them to you. You do not have to memorize them. But what they're saying is if I have the summation of a constant, I'm just going to multiply that constant by the number of terms. So if I had something that was written as I is equal to 1 of 6, and I was going up to, let's say, 10, to find that summation, instead of adding 6 plus 6 plus 6 actually 10 times, you're just going to make that 6 times 10, and you would get 60. If I have a summation like we did before, the 1 plus 2 plus 3 plus 4 plus 5, so the one we started at the beginning earlier was this 1 through 7. So instead of doing that 1 plus 2 plus 3 plus 4, I can substitute that in. My n would be 7, so it would have 7 times 8 over 2. Then these would simplify, and I would have 28. So that's going to work every single time. So that's a shortcut to doing that. So for I squared, I'm going to do I is equal to 1. Let's go back to the one that we just did, which was 8 of I squared. So my n in this case is going to be 8. So I'm going to say 8 times 9, and then 16 times 1, which would be 17 all over 6. That'll be 4 and 3. That'll be 3 and 1. And I'm going to multiply that, and I am going to get 199. So those are just shortcuts. And then there's one for cubed as well. So how do I use those? Well, if I have something written like this, and it says use the properties to simplify and then evaluate the sum. So I want to evaluate the sum for n is equal to 10, n is equal to 200, and n is equal to 500. So the first thing I'm going to do is I'm going to write this. So I am going to think of this as k is equal to 1 of n, and then I'm going to think of it as 2k squared minus the summation of k is equal to 1 of n of just 1. Then here I'm going to bring this 2 out in front, so I'm going to have 2 k is equal to 1n of k squared minus, and then I'll just rewrite this like this so we're in the same format. Now I'm going to use my properties. So the first one I'm going to do is something squared. So up here, something squared is this guy here. So now in place of the k, I'm going to write n. This 2 is still coming out in front. And then I'm going to have n times n plus 1 times 2n plus 1 all over 6. That's going to be this. Then I'm going to have minus and then this would just be 1 times n, which is n. We're leaving as 1n. So that one was using this guy here. Now, I'm going to simplify this. That's the object, is I want to simplify this. So I'm probably going to simplify the 2 and the 6 and make this over 3. Then I'm probably going to FOIL these two first. So I'm going to have n times 2n squared plus 3n plus 1. I just FOILed those. This is all over 3 minus n. Then I'm going to have distributing this n, 2n cubed plus 3n squared plus n. This is all over 3 minus, and then so I can combine them, I'm going to rewrite this n as 3n over n. Oh, no, 3n over 3, my bad. And now combining my like terms, I'm going to have 2n cubed plus 3n squared minus 2n all over 3. So now when I want to substitute in 10, 200, and 500, now that I've done all this work, I'm going to go to my calculator and I'm going to type that formula in just the way I see it. So two n cubed Okay, so if I want to use the n, I can use the n. I'm going to hit Control Divide so I have that fraction and I don't have to worry about it. And I'm typing in what I had, which was 2n raised to the third power plus 3n squared minus 2n. And this is all over 3. And then I'm going to get outside that fraction, and then I'm going to tell my calculator what I wanted to substitute in for n. So that's that such that key that we talked about earlier this year. So I'm going to hit Control equal and go to that straight line. That's the such then. And then I'm going to do n is equal to 10. And I'm going to get an answer of 760. And then it wants me to evaluate at 200. So I'm going to go up and grab this whole equation again, and I'm going to back it up. And I'm going to type in 200. Hit enter, and I'm going to get that 5,373,200. And then finally, it wants me to evaluate at 500. So if you're going to have to evaluate it more than one place, I highly recommend the such then. That way you're only typing in the equation once, and you're going to want to simplify it before you type it in. Oh, whoopsie, let's get this guy out of the way. And that's what I have for that one. All right, so I hope that helps. So now let's talk about how we're going to use the summation to find the area underneath the curve, because that's why we're learning the summation, is to find the area underneath the curve. So let's say, first thing I have to do is I have to talk about the difference between inscribed and circumcised. So what that means, circumscribed, I said that wrong. What that means is that you're going to have different ways of drawing. Remember I said we were going to draw rectangles, because finding in the area of a rectangle is just simply the height times the width, and I'm going to find the summation of those. So if I have, we're going to do 4 basic shapes here. So, and I'm not talking about concavity. I just want to draw some shapes. So I'm going to have one curve that goes like that, and I'll have this curve go like that as well. And then I want to have one curve that goes down, so it goes down like that. So when I go to draw rectangles, when it's inscribed, I want to draw the triangles based on the lower dimension. So when I talk about drawing a triangle or rectangle, I'm going to do something like this, where to find the height, I'm going to go to that space here, and then I'm going to draw rectangles. So when I draw these rectangles, notice that I'm using, I'm going to be, my estimate, since I'm going to have these gaps, is going to be an underestimate. And so now I'm going there. And I'm going to have that. So when I do this, I'm going to have like all this blank area that's underneath the curve that's not accounted for. And that's what's going to happen when I have an inscribed rectangle. So if my curve goes the other way, I'm still doing the same thing. I want the lower area. So I'm going to do something like this. I should have made that go. I feel like my curve isn't very good, so you can't really see that I'm going under, but I am going under. Oh, I guess I didn't really go under. So there you go. So I'm going to have this little area here. Now when I do circumscribed, I want the greater area. So I am going to, like if I draw my rectangle like this, whoopsie there. It's going to bother me, so I have to get rid of that. Oh, should never try and fix. All right. So as I continue to draw these, you can see that I'm going to include area in these rectangles that's not underneath the curve. So this is going to give me an overestimate. So I'm going to go do the same thing down here. So when I ask you to draw these rectangles, you're going to have to be careful whether you want to find a inscribed or circumscribed. So kind of have to have more of a curve so you can see. And so that you're going to have the over area for those ones. So that's going to be an overestimate. So let's just start to do one, and then this is about as far as we're going to get. So I have, it says use the upper and lower sums. Oh no, and I guess I didn't really say this. This is going to be a lower sum because it's going to be lower than the actual value. This is going to be an upper sum because it's going to give me a higher value than the actual the area. So you have a lower sum and an upper sum. So use the upper and lower sums to approximate the area of a region using 6 sub-intervals of equal width given the formula. So this curve here is at 9 minus x squared. I want 6 sub-intervals. So I want to draw 6 rectangles. So the first thing I have to figure out is how wide these rectangles are going to be on the base. Because between here and here, I want to have 6 because it tells me between the area of 0 and 2, I believe, somewhere. Well, it should. We'll just put that there. So the easiest way is to take the 2, because that's the area I have to cover, and I want 6 sub-intervals. So each one is going to have a base of 1/3. So to my best, I am going to draw 1/3. These ones are going to be based on the lower, so this would be about 1/3. This would be about 2/3, 3/3, 4/3. Okay, obviously I'm not drawing the scale, 5/3. So when I make these rectangles, this is how I'm making these rectangles. Oh, I forgot the 1. I forgot the 1 at 1. Don't you hate that? I do. And that's because I already had a line there. So let me erase that. Okay. So I have 1, 2, 3, 4, 5, 6. I have 6 rectangles. Now to find the area, it should make sense to you. To find the area, you're going to take, like to find the area of this first triangle, because this is what you're actually doing, but you're not going to ever do it this long and complicated. So let's do one long and complicated first. So to find the area of this rectangle, this guy right here, my base is going to be 1/3. So area is equal to base times height. So my base is going to be 1/3 because that's the width of my rectangle. And then my height is going to be what I get here, which is going to be f of 1/3. So I guess I could put, so the height would be f of 1/3. So that would be 1/3 times 9 minus 1/3 squared. And I do that for 1/3, 2/3, 3/3, 4/3, 5/3, and then 2. And I could sit there and do all that, but that seems like an awful lot of work. So I'm going to come up with a summation formula. So I'm going to start with a summation. I'm going to start with 1, and then I'm going to stop at 6 because I want 6 intervals. And my formula is going to be the 1/3, because I'm still going to have this 1/3 times everything, times, and then see how when on my first term I have 1, so I can just make that an I. So 9 minus I over 3, this thing squared. And then I'm putting in a bracket because this whole thing has to be times 1/3. So there's what I have when I first write it. I'm going to want to simplify it. Well, I'm going to want to simplify. Well, yes and no. So if I throw this into my calculator as it is right now, I will get a correct answer. So let's throw it into the calculator right now. So I'm going to do a summation. So there's my summation. Oh, I picked up my marker. I can't do that. Pause, please. Okay, so I'm hitting the summation. And there's my summation. I'm going to, let's try that again. Okay, there we go. And then I'm going to start with I is equal to 1, because that's what we said we were going to start with. I said that my formula was going to be 1/3, so I'm hitting my favorite button, Control Divide. That stops me from making lots of mistakes. 1/3, and then I'm going to say times, and then I'm going to put in parentheses 9 minus, doing my favorite button again, Control Divide, I over 3, and then I'm squaring that. That's not what I wanted. Let's back it up here. Let's put a parenthesis here, and then let's put a parenthesis here, and maybe, still didn't work. Don't you hate that? Let's make that squared. Now, does that look like what I want? Yes, just the 1/3 is squared, and then I'm stopping at 6. And it's telling me it doesn't like something. What does it not like? Okay, apparently for this to work, I have to simplify it, which is fine because I like doing math. So here we go. Do we agree that this is just going to stay here? I is equal to 1, 6. This is 1/3, 9 minus, and then this will be I squared over 9. Because when you square the I, square the 3. Then if I distribute the 1/3, it didn't like the multiplication. I'm going to have I is equal to 1, 6, and I'm going to have 3 minus, and then this will be I squared over 27. So when I put it in my calculator, I did that summation. I did 3 minus I squared over 27. You have to be in parentheses, that whole thing. So I did that, and I got 395 over 27. I'm not sure if your calculator is going to give you that fraction or if it's going to give you the decimal, and the decimal is 14.6296. So now what I want to do is I want to show you how you do that if you weren't going to use the calculator and you were going to do it using the summation formula. So if I were to use the summation formulas, I have it written very nicely up here. So I'm going to separate this into two summations. This will be one summation of the 3, and then the other summation will be this I squared over 127. So when I write that, I'm going to do the summation of I is equal to 1/6 of 3 minus the summation of I is equal to 1 of 6. And I'm going to think of this as 1/27 times I squared. So when I do this, this will just be 3 times 6 minus, and then I'm going to bring out the 1/27 in front. So basically I'm taking this, bringing that out front, and now doing the I squared. So when I do the I squared, I'm using that summation formula that we used before, which was and they're right here. Whoopsie. They're right here. So I'm using that one for n squared. And I'm going to do 127 times 6. 6 plus 1 is 7. So that's 12, 13 over 6. So when I do that, I'm going to have 18 minus, and then the 6's will simplify. That'll end up being 91. So 91 over 27. And when I do that on my calculator, I got that 395 over 27, which is approximately equal to that 14.63, which is what we got on the other one. So when I go to do the other one, when I go to do this one where I'm doing the overestimate, so here's my 1/3. I'm drawing my triangles every third. I'm using the higher number to draw my rectangle. So I have that overestimate. So when I go to do this, I'm going to have 1, 2, 3, 4, 5, 6 rectangles. Notice I'm going to start at 0. 0 is going to be my first height. So 0 is my first height. So 0 is my first height. And then this last height will be that 5/3. So to adjust for that, I'm going to have the basic formula that I had before, except for instead of just using I here, I want it to be 1 less. So I'm going to use I minus 1. So still the 1/3 is the base. The formula is still 9 minus. Now I'm going to make this I minus 1 over 3, and then this will be squared. So pause, please. So this one I put into the calculator just the way I see it, and for some reason it worked this time, and I don't know why it didn't work the other time, and I got that 55 over 27. I'm not sure if you guys will get that 55 over 27 or if you will get the decimal for that, which, let me get the decimal, which is 2.03, so that's not right. Ugh. All right, moving on. We'll go back and do it the other way. So if I simplify this, because I do like simplifying it better. So I'm going to simplify this one first. So when I simplify it, I'm going to do it the same way I did over here. I'm going to think of it as I'm going to leave that 1/3 there for a second. I'm going to have 9 here. When I square this, that's going to be I squared minus 2I plus 1 over 3 squared is 9. Then when I distribute that 1/3, I'm going to have 3 minus I squared minus 2I plus 1 over 27. Now what I'm going to do is I'm going to use the properties of sums, and I'm going to separate it. And I'm going to separate it into actually several things. So there's my formula. So down here, I'm going to do I don't want to skip steps, but I do want to skip steps. I'm going to put that 1/27 out in front. And then this will be I squared. then technically you're going to have minus, bringing that 2 out in front of just I, and then plus the 1. So when I do all that, I am going to have, this will be 3 times 6 minus 1 27th, and then I'm doing the n squared, so I'm doing 6, 7, 13 plus 1, 13 over 6, minus 2 times the quantity of, oh, that's the 27th. 2 times just I, oh, which I didn't write that down, my bad, which is n times n plus 1 all over 2 plus 1 times 6. So when I do all that, I'm going to have 18 minus 1/27 times, that'll end up being 91 minus 42 plus 6. So 18 minus 55 over 27, oh, that's what I forgot. And then when I subtract, I'm going to get 431 over 27, which is approximately 15.96. So I want you to notice that this one, which is my upper limit, is more than this one, which is my lower limit. And that should make sense if you go back to the pictures, because here I'm missing this part of the area that I did not calculate. And over here, I have this extra area that I calculate. So that's why the upper one is larger than the lower one. All right, here is the only thing you're going to have to do on this section is this page, and I will see you next time.